Let's quickly do some recap of yesterday. So cosine of 5 pi over 3. 5 pi over 3 is in the fourth quadrant because it's slightly less than 2 pi, and it is a pi over 3 reference angle, which is a 60-degree reference angle. So I have 1 square root of 3 and 2. That's a negative y value though. So now I'm looking at the cosine. Cosine is x over r. So x over r in this case is 1/2. Tangent of negative 11 pi over 6, so I'm going in this direction, and 11 pi over 6 would be a pi over 6 reference angle, and it's slightly less than 2 pi, so that means that it's actually going to be in the first quadrant here. So I have a 1, a root 3, and a 2, and then I'm looking at tangent. Tangent is y over x, so in this case, I have 1 divided by root 3, which if I used a FAFU or a fancy form of 1 where I multiply the top and bottom by the square root of 3, I end up with root 3 over 3 as my answer. Now let's take a look at a slightly different problem. Consider that cosine of A is negative 2/3, and A is in the third quadrant. So if A is in the third quadrant, here's my angle. Cosine, recall, is x over r, or adjacent, because remember, the x is always the adjacent side for our angle, and the y is always the opposite side, adjacent over hypotenuse. So I have x is 2, well, it'll be negative 2 basically, and the radius is 3. So now in order to find y, I can use the Pythagorean theorem. So 2, or negative 2 squared, plus the y value squared equals 3 squared. This will end up being 9 minus 4. So y squared equals 5. So y equals plus or minus the square root of 5. Since we're in the third quadrant, we know that this will be a negative square root of 5. So now I need to find cotangent. Cotangent of A is going to be the x value divided by the y value. So the cotangent of A is going to be negative 2 divided by negative square root of 5, which is 2 over negative square root of 5, or I'm sorry, 2 over square root of 5, because the negatives cancel out. And then since there's a negative on the bottom, I have to multiply the top and bottom by root 5. So I get 2 root 5 over 5 is the cotangent of A. Now, what happens if we're not at a reference angle that's nice? Well, there's two options. Option one is if, let's say, we have pi over 7 or something that we don't know, then what we're going to end up, well, there's actually three options. Something like pi over 7 that we don't know and is prime to all of these numbers, we would probably use a calculator in order to figure it out. Number two, if we have something like pi over 12, which we actually could get with addition or subtraction from these problems, we can do this without a calculator, but we have to wait until next chapter to figure out how to do problems like that. And then the third problem that we're going to talk about is, what if I have a quadrantal angle? Now, a quadrantal angle ends up where we have no triangle. We're about to take a look at triangles on the coordinate plane, and I have listed on the side sine, cosine, tangent, cosecant, secant, and cotangent. And so let's just kind of take a look at what happens. So I currently have it at the pi over 4 reference angle. So we can see root 2 over 2 as sine and cosine, root 2 as secant and cosecant, and then 1 as tangent and cotangent. Well, as I get this triangle to be smaller on the y and bigger on the x, notice what's happening is that, like, if I get to a pi over 6 reference angle, the cosine is getting bigger, the sine's getting smaller. That's pretty common. Now, as it gets even smaller, notice what's happening. My sine is getting even smaller, even closer to 0. My cosine is getting really close to 1. because x over r can't actually get to be 1. But if you look at the red segment, it's almost as big as the black segment in this case. Notice that tangent is really close to sine, but not quite. That's because since tangent is y over x, if I take a small number and divide it by something that's really close to 1, I'm going to get something that's really close to the small number. Now, cosecant and cotangent are getting really big, and they're going to get really big really fast. Like I just made one more slight adjustment, and they went from over 5 to over 11. If I made even more adjustments, it would get even bigger way faster. And that's because I'm doing the radius divided by x or y divided by x for cosecant and cotangent respectively. Now what's happening is since x is getting really small, I'm dividing by a number that's very small or very close to 0. So those are getting huge in that case. Now, as I actually get on the axis, I no longer have a triangle. But even though I don't have a triangle anymore, I can still use my definitions. I just can't use opposite and adjacent and hypotenuse anymore. Remember that the opposite side is always the y and the adjacent side is always the x, since my angle is right where my mouse is. So because that's the case, as I get on the axis, I have sine is 0 because y divided by r is 0 divided by 1. Cosine is 1 because x over r is 1 divided by 1. So in this case, and remember these are ratios, so it doesn't matter how big the triangle is. If I change the scale, the sine and cosine are still going to be the same. Tangent is y divided by x, or sine over cosine. Well, that's 0 divided by 1 in this case. Cosecant and cotangent, notice, are undefined. Now remember, that's because these numbers were getting really big as I got this triangle to be closer to being just a straight line or a line segment. So x is 0 now. So if I have r over x for cosecant, or y over, I'm sorry, cosecant is r over y. So if I have 1 divided by 0, that's going to be undefined. And cotangent is going to be x divided by y. That's 1 over 0 also. That's also undefined. So that's kind of what happens as I get close to an axis. Now, as I get pi over 3 and then even closer, notice the opposite things are happening. Sine's getting really close to 1. Cosine's getting really close to 0. So tangent and secant are approaching infinity, basically. And so then as I get to this axis, I have sine is 1, cosine is 0, tangent is undefined. So basically the reason why I'm doing this, and I mean, you can just kind of play around with these when you draw the picture, but you can use the y over x, x over r, y over r definitions of these things to actually figure out what's happening. The only difference as I go into the negative quadrants is that cosine and secant are going to be -1 on the negative x-axis because I have a negative x divided by a positive radius. And then as I approach the negative y-axis, I'm going to have sine and cosecant be -1 because I have a negative y divided by a positive radius, because we always treat the radius like it's positive. We have 4 quadrantal angles that we just saw on that Desmos thing. We have a quadrantal angle when theta, or the angle, equals 0. We have one where the angle is pi over 2. We have one where the angle is pi. And we have one where the angle is 3 pi over 2. Now I can do all of these in terms of degrees: 0, 90, 180, 270. And then notice that I can use all coterminal angles for this also. So I can say that this one's also 2 pi. I can say that the pi over 2 is also 5 pi over 2, and so on. So I can also use the coterminal angles in order to figure it out. I could go in a consistent pattern here. Now, basically what we have to do is we have to recall that sine is always y over r, cosine is always x over r, cosecant is always r over y, secant is always r over x, tangent of theta is always equal to y over x, and cotangent is always equal to x over y. Now, if we remember that, it's actually not that bad because we're normally, since we've been doing this since geometry, we've used triangles all the time. Well, now we don't actually need a triangle. We can use just straight line segments on these quadrantal angles, or for these quadrantal angles that are on the axes, in order to get stuff. So let's take a look at 3 pi over 2. 3 pi over 2 is going to be a quadrantal angle. It's the same thing as 270 degrees. And I can actually figure all these out pretty easily. So this is the point 0, -1. Well, that makes it really easy to do all of these things. Notice that the radius is exactly equal to the length of y. So my r is 1, my x is 0, and my y is -1. So these are all pretty easy. Sine of theta is -1 divided by 1, which is -1. Cosine of theta is going to be 0 divided by 1. That's 0. Cosecant of theta is r over y, or the reciprocal of -1, which is also -1. Secant of theta is the reciprocal of 0. That's undefined. And that makes sense because if I have 1 divided by 0, that is going to go off to infinity. It's going to be undefined. The tangent of theta is going to be y divided by x. Notice that x is 0, so that's undefined. And the cotangent is going to be 0 because that's 0 divided by -1. That's 0. Notice that sine and cosecant are reciprocals. Cosine and secant are still reciprocals. And tangent and cotangent are still reciprocals. So it works out. So quadrantal angles actually aren't that bad. 2 more problems to do before we're done. Sine of 11 pi. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 pi puts us as a quadrantal angle on the negative x-axis. So if I'm doing sine, sine is y over r. Y is 0 in this problem, so 0 divided by 1 is 0. So sine of 11 pi is 0. Cotangent of 450 degrees. 450 degrees is coterminal with 90 degrees. So that puts us up here. And cotangent of 450, cotangent is x over y. It's adjacent over hypotenuse. And if I have the point 0, 1, x is 0 and y is 1, so 0 divided by 1 gives me 0. So that gives me the cotangent of 450.